Lecture 2, Section 3 and Part 3. This is the last part of this lecture and Chapter 5. SS policies. The QR models that we had so far are in the category of continuously reviewing inventory models. So, but what if we want to have periods to review the inventory level? I mean, we're not going to continuously monitor the inventory level, and instead of that, we want to have periods, and in that periods, we will review the inventory level, and based on that we will decide if to place a new order or not. Okay, so in the periodic review, usually we have these levels. The little s here is somehow, let's say, a measure in order to obtain to place a new order or not, and the capital S, the large S here is the maximum inventory level. So if we have, let's say, U is our initial inventory at the beginning of the period, then if U is less than or equal to S, we are going to place a new order, and the quantity will be large S minus U. Okay, so as you see here, the quantity of the order is variable. I mean, it differs from one period to another period, but that's not happening in the QR models. In the QR models, Q is constant and it's optimal, and we obtain an optimal level for Q, and it will be the same in all orderings. But here in the periodic review, it's not. So anytime we may have a different quantity for ordering, and it's obtained based on the maximum level minus the current level, I mean the initial level at the beginning of that period. But if U is greater than S, then there will be no order here. Okay, so analyzing the periodic review based models is more complicated compared to the QR models. So we're not going to have those models in our course, but we can have just a good approximation here. We can approximate the 2S here, so we can assume that the model is based on continuous review, and then we can obtain R and Q, and then by having this, now we can set the 2S, I mean little s and large s for the periodic review, as the little s will be the reorder point, and the capital S will be R reorder point plus the Q as the maximum level for the inventory. Okay. So let's have a discussion here for the complexity of the inventory control problems in the real world. A medium-sized manufacturing firm may have 10,000 SKUs. SKU is the stock keeping unit, so they are the units. Okay, doesn't mean that the 10,000 units are totally different products, different goods. No, it's not. It's stock keeping unit. So stock keeping differ in size, so same good, same product, but different size. Packaging, again, same size, same good, same product, but different packaging, or perishability, storage need, and so on. Okay, so, and also a department store may have 100,000 SKUs. So as you see here, we have huge number for the items, and if you want to continuously monitor all units and then obtain the reorder point and the quantity of the ordering for each unit, that's not possible, right? It's a lot of work. So here we are going to somehow prioritize the items, the goods in our inventory, and then we'll have different policy for each category of the items. Okay. So here the approach, for example, let's have an example here. If we have an item and we need to spend $200 a year to monitor the inventory level for that good in order to obtain when and how much to order, but If that item contributes to our annual profit just $100, then is it justified to spend $200 to monitor its inventory level? No, it's not. Yeah. So as you see here, it's not justified for many items in our stock to continuously monitor the inventory level and obtain the reorder point and quantity and so on. So this is actually uh, the reason that we need to prioritize the goods and the items in our inventory and have different policies for each category. So we do this by the ABC analysis. Okay, so by ABC analysis, we can categorize the items. Okay. The ABC analysis is based on the Pareto curve, and I think you had this approach in your previous courses, so I'm not gonna explain the details. So in this approach, we categorize the goods in three categories by this criteria that the first 20% of items account for 80% of our sales, and 30% of our goods or items account for 15% of our sales, and but 50% of items account only for 5% of our. So these numbers are approximate. So we may consider 20% of items with 75% of sales. That's good. Or for yeah, here we call this as A, and then B and C. Okay, category A, category B, and category C. So yeah, for example, category C may account for 10% of the sales, not 5, or B may be 20%, not 15, or 16, 18. Yeah, I mean, these are just an approximate, and this gives us a picture that how can we categorize the items in three categories of A, B, C. Okay. And yeah, and so in this figure here, you see that approximately 20% of the items account for 80% of the sale based on this exponential curve as the Pareto curve here. And the B, let me show with different color here, the B, 30% for 15% of the goods, and the rest of 50% of sales just account for, I mean, 50% of the items just account for 5% of the sales. Okay. So now here we can set our policy for items in the three categories. So for A items, since they are most valuable items, we can set our policy for continuously monitor the inventory level and set our optimal decisions as QR inventory model. Okay, and also we can have a very good forecasting models and also great care about the cost parameters estimation. Okay, so yeah, as you see here, we spend a lot of time and also budget in order to have accurate models for A items. For B items, for B items, yeah, inventory should be reviewed periodically. So yeah, it's not justified to have continuously review-based models for B items. So here we can consider the periodically review-based inventory models for B items, and here also we can group the items and have actually group orders based on the groups, not individually for each item. And less sophisticated forecasting methods should be used here. And for the C items, they are very inexpensive items. So with moderate demand, so here we will have, if demand is moderate, so we'll have minimum degree of control, large lot sizes. So yeah, here we'll have large lot sizes to minimize the frequency of orders since they are so inexpensive. So the H equals I times C will be a very small number. So it's justified to increase the size of the order. Okay, and with low demand here, maybe it's better to not hold any inventory. Okay, so this would be our policy for items in three categories of A, B, and C. Okay, so let's have an example here. Here we have this data: part number, price, yearly demand, and dollar volume. Okay, and now by having the dollar volume, I mean the total sale or revenue coming from each item, we can categorize these items in three categories of A, B, and C. So here we have an example. We have these items, price of each item, a yearly demand, dollar volume, and a cumulative dollar volume. Okay, so yeah, as here for the cumulative, the total dollar volume is this 21,983 for all items. Okay, and here this cumulative for this number 17,609, if we divide this number 17,609 by 21,983, let me write here, yeah, 17,609 0.56 divided by 21,983.84, it will be close to 80%, 0.8, okay, almost 80%. So as you see here, these items, one, two, three, four, yeah, just four items contain 80% of our total sales. So this would be category A here. Okay, and these items from here up to here, yeah, if we subtract 2861.11 minus 17, yeah, let me show here, 20, yeah, so from 17,609 for group A, and then divide this by the total sale value, which is 29,983.84, then we obtain a 14.8%. Okay, so as you see here, about 30% of items contain 14.8% of the total sale. So this will be our group B. Okay, so this will be our group B here, and the rest of items will be group C. Okay, so we are almost done on this chapter, and the last discussion here is about the research areas. The models that we had in this chapter reveals actually the tip of the iceberg in terms of the vast quantity of research done on these topics. Yeah, so I can say in the research area now they are working on multi-echelon inventory systems. So here they assume that there are multiple locations to store the goods, and they are linked by a network. For example, we have a supply chain here, okay, and then for that supply chain they should obtain the optimal level for the order point and for order quantity, and also they are in the research area they are considering items that change during the storage. So yeah, I mean they have I mean variable status during the storage time in stock. So for example, they may perish over time, or they may lose their value over time in the inventory, and this will impact on the order quantity and the order point. Okay, so okay, we are done on this chapter, and this was all about that we have for inventory models with uncertain demand. Okay, I will wrap up the models in our live session on Tuesday. So yeah, I will have a picture, I mean a big picture on the models that we had in this chapter and how they are different, and when and where we should consider and apply those models. So see you on Tuesday in our live session. Okay, thank you.